Hey, course 3, today we're going to find the area of a polygon, particularly polygons that you divide into separate polygons, like this 1, 2, 3, 4 sided figure, but has a kind of a triangle end, an angle end. To find the area of it, we're probably going to want to think of it as 2, so they divide it like that, and then we are enabled to think about, okay, this times this, right? Length and width is 24 of this. And then what's the area of a triangle times the base times the height, and divide that all by 2. Don't forget that part. So 2 times 4 is 8. Divided by 2 is 4. Right? 8 divided by 2 is 4. And then you just add the two areas together to get 28 square centimeters because it's area. You can also use a calculator and you can estimate area in some cases in life if that's all you really need. So in this case we have kind of an upside down and elongated version of the figure we just had. We divide the figure into a rectangle and a triangle like you see here. Knowing the hypotenuse and one side, and that this is a right upside down right triangle, we're going to use these two measures and the Pythagorean theorem, you can't escape it, to find the missing side. So think of it as a triangle like this, right? You got your right angle, the height of 100, and we don't know the base, but we know the hypotenuse is 110. So we say 100 squared plus, we don't know, squared equals 110 squared. Okay, and they tell us 110 squared is 12,100. 100 squared is 10,000. And we still have our x squared. Subtract the 10,000s. Now it's just x squared is 2,100. Square root of those, x is actually an even 46. So you take that back over here now. This x is actually 46, thanks to this Pythagorean theorem. Find the area of that. 46 times 100 divided by 2 is 2,300 feet squared. Add that to the rectangle, which is 60 times 100 is 6,000. Comes to a total of 8,300 feet squared. Probably the hardest part of that was the algebra that we did over here with the Pythagorean theorem. We haven't done a lot where you're missing the base, so something to look over and get more comfortable with. In this figure, AD is 40, DC is 30. So that's talking about AD would be from A to D is 40. DC is 30, that's from here to here. Point B is the midpoint of AC. So that means that from here to A to B is the same distance as B to C. And point E is the midpoint of AD. So this right here is a perfect bisection. Find perimeter and area. For perimeter, we would probably do a Pythagorean theorem with 40 and 30 set up like this. 40 squared plus 30 squared is c squared, because it's the hypotenuse we're missing. And then once you know C, you'd add, and I'm guessing it's a 3, 4. Is that a triangle? A triple is 3, 4, 5. Not positive. I think it is though. 3, 4, 5. So it's probably 50, which would mean it's 120 perimeter. We'll check on the next page. Meanwhile, area we can do because we don't need the hypotenuse for area. We know that these are exactly equal, AE and ED, so it's 20 and 20 and 15 and 15. We don't need that. To me, you just do 30 times 40 divided by 2. Let's take a look. I don't know why we would need to break up the triangle unless we need to tell what each triangle is. I got the perimeter right. Well, since triangle ACD is a right triangle, we can find that AC is 50. That's what I said. A midpoint of a segment divides a segment in half. They want EB so that, yeah, they can do they want the separate areas. Pretty complicated problem. We can talk more about that one in class. Why don't you try A and C? Take some time to get those right, and we'll talk about those in class as well.